Hello and welcome to NARC Live on Wednesday the 7th of May 2025. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7RP. Lovely to see you. On tonight's show, we find out how to automate and make operating your shack easier with Bob, N6TV. We look back at the club's 2 special events run since we last met. And we find out what on earth this is, or what these are, or what they're for. Extra points if you know what they're called as well. If you haven't already, we've had lots of entries actually for this, surprising I think. But if you haven't already answered it, you can put it onto BATC or on Facebook, and we will include you when we get to that part of the show. But I'm sorry that we have to start the show with some very sad news. NARC member and good friend to many, Ken Noakes, M0HGR, is now silent key. I cannot claim to have known Ken very well, but he always seemed a gentle and kind sort of man who, as well as being a NARC member, was a valuable part of our training team. Paul G3VPT sent me these words to share about his very good friend. Over 50 years ago, my wife Linda and Ken's wife Carol both worked in the same insurance office in Norwich, and we got to know Ken that way. At that time, Ken worked in the motor trade, but also had an interest in radio. Ken was involved in the foundation and intermediate training at the club, and he was just going to sit in the full licence course when David talked him into sitting the full exam. Ken spent many hours at home with Paul, going through all the exam papers they could find. Ken also liked trains, and they took part in many Railways on the Air events with the club, and he'd often help with Jamboree on the Air with the local scouts. He will be very sadly missed. As you can see there, the picture, both these pictures actually were taken at Railways on the Air events. And the one on the left was taken at the Mid-Norfolk Railway in 2019, and the one on the right was taken on the North Norfolk Railway. Ken Noakes, M0HGR, now, sadly, silent key. Well, now back to news of the club's special events that we ran at the end of last month. On Saturday the 26th of April 2025, NARC once again ran a special event station with the call sign GB0CMS at Caister Lifeboat as part of the International Marconi Day celebrations. Using the call sign GB0CMS and a mixture of CW and voice contacts, which were made with the other radio amateurs across the world. Notable contacts were with Marconi station GB0IMD at Western-super-Mare Radio Society. In 1897, Guglielmo Marconi demonstrated wireless communication between Lavernock Point in South Wales and Flatholm Island in the Bristol Channel, and then down to Breen Down near Western-super-Mare. This was the longest distance ever covered until then, 13 kilometres or 8 miles. Other stations worked included a station in Brazil, as well as numerous stations on the east coast of the USA. Thanks to everybody who partook in that event, and to Steve, who organised it as well for the club. Now, NARC also organised a special event station GB80CHO at the 100th Bomb Group Memorial Museum over the same weekend, the 26th and the 27th of April 2025. Operation Manna and Operation Chowhound were important humanitarian food drops to relieve the famine in Holland behind Nazi lines late in World War II. 2025 commemorates 80 years since these momentous operations by RAF and USAF personnel for the first time using aircraft bombers to drop desperately needed food aid. Several groups of radio amateurs around the world mark this with special event stations and awards, and in addition to GB80CHO, which we ran near Diss in Norfolk, and GB80MAN in Lincoln, there were other special event stations also marking the event in the Netherlands, Canada, United States, Poland and Australia. Our station, GBATCHO, logged 283 contacts over 2 days, working on HF, VHF and DMR, working from the USA through most of Europe to the Ukraine. The log from all these special event stations, incidentally, can be seen on qrz.com for the call sign GBATCHO. And finally, last weekend, the NARC member Gordon G3PXT and friends operated as a portable special event station, GB2CLS, from Case to Lifeboat Station. That was just this last bank holiday weekend. Well done to Gordon for organising it. You see Brian there and Mike with him as well. Hope they saw lots of visitors as well as putting on the special event station for radio amateurs. It's a nice time and a nice opportunity to share our hobby with other people. So thanks to everybody involved with all three of those events. Now, we've just got a few details about Barford Radio Rally. I seem to be asked a lot at the moment. It is going to appear in the magazines like Radcom and Practical Wireless soon. And it's also already, I think, on the RSGB website. But here we've got a slide with just some basic details for you. So if you've been wondering if it's happening, it is happening, and it is happening from our usual place at Barford Village Green with the Village Hall as well. This is the key information you need. It's on Sunday the 6th of July, 9 o'clock until 1 o'clock, open to the public, open an hour before that for traders to set up, either outside or inside the hall. We have a few tables inside the hall at £10 each, or traders' pitches outside will be £8 for the whole pitch. All right, the ones inside the hall, though, there's a very limited number of those, so you will need to book that with me as soon as you can if you want an indoor table. And I don't know what your weather forecast is like, but I have no idea what it'll be like on the 6th of July. But normally, where's some wood, Tammy? Tap my head. We do get very nice weather for that event. We've been very, very lucky over many years. So anyway, so there's the details. Sunday, the 6th of July. It's definitely happening. I know there's controversy about what's happening to Barford Village Green, maybe with some building work in the future years, but it's absolutely, definitely happening this year at the very least. All right, so contact me if you need any further information. You don't need to book outside pitches, but you do need to reserve indoor tables if you want one. Now, just time for one piece of members news this week, and this came from James M0 UKS and Lynn, who I'm delighted to say, did you know, Tammy, they've had some babies? Did you know that? I'll get killed for that. Let's have a look at their babies. Oh, that's from their bird box, of course.
Sid the squatter.
This is Sid the squatter's box, is it?
Yeah. Yeah.
How many are there, Tams?
Oh, I don't know. 1, 2, 3, 4, 5.
Really? God, they're quite close.
5 or 6? 2, 3, 4. There's definitely 5 there.
Good. Well, congratulations, James. Thanks for that picture, and to Lynn, of course. Thanks very much to the happy couple, really, we could say. All right. Thank you very much for sending that to us. That's today's picture as well. Look at the date and time from 10 to 5 this morning. Now, we've got a little extra picture to show you now. When we were at the GBATCHO event, as you know, the 100th Bomber Command near Diss, they don't own the land anymore, but behind them are still the runways that took part in that. And when we were leaving, they asked us to leave in the sort of back road, which actually happens to be the runway. And I couldn't help to take a picture from the car as we left. Tammy was driving, I hasten to add, because I don't know if you can see this, but this is what the runway looks like down there. And the next picture will show you a little bit more. If you can have a look at this, you can see that the vehicles from all of our colleagues who were helping to set up the mast that day were just ahead of us on that. And we thought it looked like one of those scenes from Top Gear, didn't we?
Yeah, racing down the runway.
Yeah, they used to say, some say the Stig. Anyway, it was just a bit of fun, and we took those pictures and we thought we'd show them to you now.
Sorry, James just commented, there's 6 babies.
Oh, 6 babies. All right. Yep. Well, do congratulations to the happy couple, as I said. All right. Now, we've We're now going to come to the competition. No,
Are
we're
we-
not.
are
We're
we
going to do
gonna
Little
do
People. I'm
Little
sorry,
People
I nearly got it right, and I write
Okay.
the script and I get it wrong. Tammy, over to you for Little People. We'll edit that bit.
Here's
This
Little
is not
People this
live.
week. So, as many people may realise, it was May the 4th this week. So, a new type of droid.
Oh, cool. So on the right, we've got R2-D2.
Yep.
On the left, Tammy, we have...
Another droid. I'm not
You
sure.
didn't- I thought
not
you
sure what
being
its
a
designation is.
Star Wars
It looks
fan,
a bit
you
like
know.
R2-D2 with a different top on, actually. To be
But the
fair.
one in the middle is a
Yeah.
yogurt pop, which is rather good.
I thought it looked quite cool, actually.
It is good, isn't it?
Yeah.
We always say this, but it is an ingenious calendar. A new picture every day, miniature-calendar.com. It's a Japanese website, and I don't know how they do it, but every single day, we've been doing this for 5 years, I think, and nearly all that time we've been doing Little People.
Yeah, most of the time, I think, yeah.
So there's lovely pictures there. Thanks for picking that out for us, Tammy, for May the 4th, which was 3 days ago. But there we go.
Well, you know, it's close enough.
That's right. Okay, so now, do keep in touch with us, by the way, about sending us your news. If you've got any babies or anything like that in your wildlife, this is the address to send it to, for anything to do with the club, really, but certainly to do with NARC Live. radio@dcpmicro.com will be on air again in 2 weeks' time. So get it to us by about 3 o'clock on that afternoon. So plenty of time. Please do keep in touch, though. So now we come to that competition that we set 2 weeks ago when we asked you, what on earth is this or these?
This or
Or
these?
what are they for? Now, have we got anybody? I've got to look online to make sure nobody has entered that. No?
No, not online, I haven't.
Okay, so we've got quite a lot of entries, though. So here we go. Take a deep breath, Tammy, and here we go. Steve, G3EVA, says this week's items are puncture repair tools. I thought they'd make a puncture rather than... Anyway,
Yeah. Andy M0NKR, the next what on earth is a set of tools to repair a puncture, screw to clear the hole, and the other, the rubber puller.
Bruce G4KZT says tonight's what on earth is tools from a temporary off-road tyre repair kit.
Paul G3VPT, I think I know what they are. On the left is an opener to engage the tag to wind the lid off to open a tin of Spam. Oh,
I see that actually, yeah.
yeah. Hang on, I've lost where I am now.
And the
Because I
other,
laughed. And the other item is to remove a cork from a bottle of wine. Well, yeah, he's not wrong, is he? On
No.
either of those.
now we're just. Are we going to break? No, we're going to talk to our guest in a minute. Aren't
We
we?
will
We're
in
going to
just a
bring him
moment.
in a
Yep,
minute. Yeah.
yep.
Tom G8XQD. These are historically the tools for repairing a tubeless tyre puncture. One tool roughens the hole, the other takes a rubber worm and inserts it after being covered in a rubber adhesive solution. Recently, I threw away my set. I'll get the RAC to make my repair or a tyre fitting place, he says.
Colin M7OPB. These are for putting plugs into tubeless tyres. One reams the hole out and the other pushes in the repair and leaves it in the tyre when you pull out the tool.
Padge 2E0KJX says they are motorcycle puncture repair tools.
Ralph 2M0RHT.
I'm glad you got this one.
Oh no, better read this properly. Are the two items a brad awl and a screw awl for woodwork? Just hope the a corkscrew item can also be used for opening bottles of the red stuff.
Mike GAEY says, I've not seen these since the 1960s when vehicles went more slowly. They are tools used for the repair of punctured tubeless motor tyres. One is a reamer used to clean out the hole made by a naughty nail or screw, and the other is used to push a repair strip covered in rubber cement into the hole to plug it.
There's a theme going on here, isn't there?
There is a theme, yeah.
Paul 20NLX, the object this time is a tool for twisting in a hole in a tyre puncture, then pull in and out to clean the hole. And then the one that looks like the end of a big needle is for holding a really sticky piece of rubber that looks like a piece of licorice. Well, that's different. This is then pushed into the hole.
Okay, now we have one extra entry. We've never done this before, I don't think, but we have our guest, Bob, N6TV, is waiting patiently in California to join us to give us our talk tonight. But he said, I've seen that competition and I'd like to enter. So who are we to refuse? So, Bob, we're going to bring you in early. Hello, nice to meet you.
Hello. I'm kind of in agreement with most of those folks. It definitely has something to do with tires, either for repairing a tire or for inserting the valve stem in a tire. That's my guess.
Is it fair to say that you've had a bit of an advantage because you've had lots of people now say it? Maybe we should have brought you in at the beginning. Is that honestly what you thought? Is that what? Yeah, we should have done. Is that what you thought it was?
I knew it had something to do with tires, and then I thought either valve stem or repair. I've seen something similar.
Okay, well, thank you, Bob. We'll be seeing you in a little while because we haven't revealed yet exactly what it is.
No, we haven't.
So thanks, Bob. We will see you shortly because we're now going to reveal and say that this is what these are or what they're for.
They are heavy-duty puncture repair kits.
And that's Bob G6 PWS. He sent us those. Actually, I will just read this. Now, he says, what you may need is a set of long nose... Oh, he said, by the way, they're called, official name is a T-handle insert tool and a T-handle spiral probe tool. So that's the official names. Nobody actually got those, but I think they all did well because I had never knew what they were. No idea at all. And Bob just says what you may need is a set of long nose pliers because you use these to remove any nails, screws or other foreign objects that have embedded themselves in the tyre. Bob says that he's repaired his own car tyres with this, but mostly used on tubeless tyres on his trucks. Wow, so well done anyway if you got that right, and lots of you did. I think only Paul thought it was something to open a tin of Spam, which I thought was a great thing.
We actually have the implements here.
By the way, can I just say, if any of you get an email from me which talks about cans of meat, don't worry, it's just spam.
Going? Hang on, where should I put,
Bob's nodding. He thought it was good.
Where should I put this?
I don't know. I was gonna. We have actually got those real items here because Bob left them with us when he gave us some components a few weeks ago. I wasn't going to be rude. I was going to say, have we got a spare tyre which I can try them in?
Whatever.
But I better not say that because it'll be the spare room for me. Anyway, too much frivolity. Sorry, Tony.
Anyway, should we look at next week's
I think we better. Yeah. Thank you very much, Johnny Bob. I don't think I'll be using these again, although we might try them as a corkscrew. Good luck with that.
Will it work on my lawnmower tyre?
Yeah, maybe. Actually. Anyway, let's get back to the script and say to you, what on earth is this? Have a look at that. Now, I know there's an obvious answer to that, but we do want to know specifically what type this is, what it's for. All right, there is a particular use for this specific one. Don't put it onto Facebook or anything, obviously, at the moment. We will be putting this picture, though, on Facebook, on our Facebook page, and we'll be putting it in the newsletter. And you've got just under 2 weeks to let us know if you know what that is specifically used for or what it's called. So Thank you very much. And thanks again for all your entries this week. It's lovely when we have so many entries. So before we meet Bob again, for the real reason he's here tonight, just to let you know what's happening this week at the club. On this Saturday, we have the Koblenz Sked, our monthly Sked at 10 a.m. on 7.123 megahertz with a local talking on 145.250. On Sunday at 7 o'clock, the GB2RS News on GB3MB. On Monday, the Monday Night Net at 7:30, also on GB3MB. And then next Wednesday, a week from tonight, we won't be here online, we'll be at the school, at CNS School, between 7 and 9:30. And we've also got, for a social informal, and we've also got Bright Sparks for our younger members. They'll be making something up cool. So that's it. So I said, please do keep in touch with us, and do say we've got this card, as you know, which we're happy to send to anybody who would be cheered by a card from Norfolk Amateur Radio Club. Just drop us their address. We'll add your name to ours and send them. Just email the details to radio@dcpmicro.com together with all your news. Thank you. So now we're going to meet Bob again, but this time for what he's really here for, because we all must have wanted to make the operation of our HF Shack easier at times. And Bob's going to give us some really good tips and ideas on how we can automate things and make things easier. So lovely to see you again, Bob.
Hello.
Hi, really good to see you. Thank you very much for joining us.
Thanks for the invite. Ready to go?
Yeah, we're ready to go. So I'll leave it to you. And of course, at home, as always, if you have any questions or comments for Bob, we'll read them to him at the end. Over to you, Bob.
Okay, so everyone, there's the screen. Very good. This talk was originally prepared for the Visalia DX convention, what we call the Contest Academy. That's what the logos on the screen there at the bottom are. NCCC is the Northern California Contest Club. So I'm going to cover some basic station automation techniques, not try to get too fancy, not talk about a lot of computer stuff. So here's an overview of the talk today, and that is why do we automate things, and actually what shouldn't be automated. There's a lot of things that'll talk to each other: transceivers, amps, band decoders, antenna switches, bandpass filters for SO2R stations, single operator 2 radio, where you're transmitting on one band and listening on another, and automated tuners, and then a summary of the recommendations. And I'll be happy to answer any of your questions at the end. If you want to note the slide number in the lower right corner, if you have a question about a particular slide, I can try to jump back to it. So why do we automate things? Well, as you probably know, I'm more into contesting, where things have to work reliably for a long period of time, and you get very tired after a long contest. You're going to get sleepy, hopefully not during this talk. But fatigue is going to lead to mistakes, and you don't want to make mistakes while you're contesting or damage your equipment and game over. So what you want to do is automate things that'll prevent at least the disastrous mistakes and keep your equipment alive for the contest. My philosophy is I'm going to let the machines do what they do best, and then I'll do the rest of the work. So there's things that obviously should automate, especially if you're in a contest. You want the computer to log automatically the date to time and the frequency, which means it has to get the frequency from the radio, the mode, and the call sign and exchange. And obviously, these days, you can call CQ and send the exchanges automated using the function keys in your logging software if it's properly connected to the radio. And when you change bands, then everything should automatically switch. The antenna, the amplifier, any bandpass filters or coax stubs you're using, which would be more appropriate for a multi-transmitter site or a single operator 2 radio situation. But some things I don't think should be automated. I think you should leave that to the human, especially CW copying. Code readers are pretty good, and maybe they'll get a lot better with AI. But I would not blindly trust every spot you see on a cluster, especially if it came from a human spotter as opposed to the automated reverse beacon network spotters, which tend to only post confirmed spots if you do it right. And then I think it sounds weird if you do automated voice keying with if it sounds like Oscar Hotel 2 Bravo Alpha Delta. I think that sounds pretty bad. And they are getting a lot better, though. So some of the AI tools can be used to automate the call sign and an exchange on phone, and those sound a lot better. But the letter-by-letter ones don't sound so good. Obviously, if you're a person with disabilities, you feel perfectly free to use any kind of system to transmit voice. This is kind of a subtle one. When you have a big pileup going, your DX in a contest, you don't really have to sign your call every time. You should sign it now and then. Well, hopefully every 3 QSOs minimum. Some rules require that. But it's up to the operator to judge, okay, there were 2 guys calling last time. There's only 1 this time. Now's a good time to sign my call when I'm done with this one. Having it automated where your logger automatically signs your call every 3 QSOs, I think is not the right way to go. And of course, figuring out what frequency to call CQ and where the clear frequencies are, something the operator should do, and not some kind of automation. So the main goal is to automate band changes because it saves time in your equipment. You don't want to transmit into the wrong antenna or the wrong band, or have your rig and amplifier on different bands when you're transmitting. It can do some damage. So I'm a big fan of hardware automation, which means not relying on a PC to do all the work. That's not always possible for transceivers like Flex that are kind of depending on having a PC do all the work. But I really think that if you're rebooting PC or Windows has crashed and you need to restart it, I think you should still be able to operate your station somehow without that until that comes back online. And this is done by using what's called the band data or frequency data that comes out of the radio, and that'll be wired to the peripherals, and then they can change bands automatically. These devices were made to work this way, and I'll show some pictures of these later in the talk here. So what happens is these peripheral devices, the band decoders and the antenna switches, they're going to use the band data out of the radio or the operating frequency. And then there's a fail-safe system with automated amplifiers and tuners that they'll have a built-in frequency counter that can override if it gets an incorrect input or your band data cable gets disconnected, for example. So how does this work? Well, first of all, for most contest or auto logging or even FT8 these days, you're going to have a PC that's connected to your transceiver, and that can be by USB cable, by RS-232 cable, or even Ethernet. And then there's a band data or RS-232 or ICOM CIV jack, which they label remote on the transceiver, and that can be fed to an automatic amplifier so that it automatically tracks the band changes and gets the transmit band and switches before you do any transmitting. That avoids all hot switching. You might also have a band decoder that reads that data in parallel and feeds an automated antenna switch. Sometimes the band decoder and antenna switch or a relay switch are integrated in one box. And for a multi-op station or a single op 2 radio, you might have a set of bandpass filters, one per band. You want them to automatically switch in. Otherwise, you're going to blow up the filter when you transmit on the wrong band. You may have an automatic antenna tuner or a step-IR tunable antenna, and it too will need to track your radio. So all of those things combined together, we need to connect them together. And the question is, how do we make that happen? Well, let's start with band data. It doesn't provide the frequency that you're transmitting on, but it does provide the band. And the band is all that is needed when you have a broadband solid state amplifier that doesn't have an automated tuner. Then it just cares about the band you're on, not the frequency. And you also, bandpass filters and antenna switches generally just need to know your band and not your exact frequency. And I'm listed there a bunch of examples of these devices, and you'll see some pictures of them later on. But if all you have is band data, it's really not good enough for the devices that really need to have the exact transmit frequency before you do any transmitting, before they can automatically switch. So this includes automatic tuners or amplifiers that have automatic tuners that you're not bypassing internal to them, and that applies to a lot of Elecraft amps, ACOM amps, and especially SPE expert amplifiers. And of course, the step-IR tunable antennas, they have a controller that needs frequency rather than band data. And then there's something called the baby loop controller, which does the same thing. So how does band data encoding work? Sorry to get down into the weeds here a little bit, but this is just a kind of a simple system that Yaesu started and Elecraft copied it. It's just a 4 pins on a connector that go high or low to indicate what band the radio is on. Unfortunately, the 60-meter band wasn't around when they designed this system, so there's now some discrepancy when 60-meter band is selected, or 5 megahertz. ICOM has a legacy system that uses just a simple band voltage, 0 to 8 volts, that indicates the band, but its system also was developed before the new bands, 12 and 17 meters, came along, so they actually can't distinguish between band data on 10 and 12 or 15 and 17 as indicated by the yellow circles there. You can get band data output from a flex, although usually that's not required, especially unless you have certain band data devices. The Kenwood radios, they do not have any band voltage or band data output at all. So you have to use RS-232 data with those. So unfortunately, all the manufacturers decided to use different connectors for everything, even though it's all the same idea. So the original older Yaesu radios used what I call an uncommon 262-degree horseshoe-shaped 8-pin DIN plug. Don't try to force a standard 8-pin DIN plug into that jack. Something bad's going to happen. And then they kind of also did the same kind of tricky thing with their FTDX10 and FTDX1200, used a 10-pin mini DIN plug, which a standard one won't fit. You have to buy a custom cable. Fortunately, on their bigger, newer radios, they used a much more standard D-sub connector. It's called a DA15. People might call it a DB15, but the correct term is really DA15. The letter A, B, C indicates the shell size. E for the 9-pin VGA type connector. 15-pin VGA type connector or 9-pin serial. So you can see they have band data pins there. And then on the FT710, Fortunately, they have gone to a standard 8-pin mini DIN plug that you can get anywhere. But then they went ahead and combined band data and RS-232 or TTL level on 2 of the pins, and you have to use a menu setting to switch what you want those 2 pins to be. So that's a difficult radio to interface with some devices. Elecraft, all of the Elecraft K3 and K4 and amplifiers, they use the same pin layout. That's a DE15 connector, 15 pins and a high density, sometimes called an HD15. And the 4 band data pins are there, as well as other pins for keying the amplifier. And this binary coding you see here is exactly the same as what Yaesu uses, but they do have 60 meters listed as all zeros here, and that's what Elecraft chose to do. ICOM has different connectors also. They're pretty standard on most of their radios with 2 accessory ports, 7-pin and 8-pin, and they do have a band voltage indicator on one of those pins, as well as a reference voltage and a ground pin. On their smaller radios, they've gone to this 13-pin to get to that data, which is another hard connector to solder yourself, but they do have an expensive OPC 99 or something like that adapter cable that splits that connector out into the legacy 7 and 8-pin DIN plugs, which are a little easier to deal with. So, but again, as I mentioned, the Kenwood radios don't have any band data pins at all or any band voltage, nothing like that. So in those radios, for a device to get the frequency, you have to talk to the radio's COM port, a 9-pin serial port. They happen to use male connectors on Kenwood radios, and ICOM and the few ICOM radios and all the Elecraft radios use a female connector. I think the female connector was the right choice for a device like, but in any, because the PC has a male connector. But in any case, they do on most of the, or all of the Kenwood rigs I'm familiar with, when they have a USB port, that provides a virtual serial port for the logging software. And so the devices, the hardware can use the 9-pin RS-232 port. And so they can operate independently. Unfortunately, that's not true of the Yaesu FTDX 3000, 5000, 9000. You have this choice in the menu, which is like cat select. And in the 3000 does have a USB connector, but you can't use it and the RS-232. It's one or the other. That's not true of the other newer radios. But the way it can work, if you want your PC and a device to control one of these radios at the same time, since there's only one usable RS-232 connector on these Yaesu rigs, is that PC software can send commands and talk in both directions to the serial port, and then the device, most of them are enabled, so they all have to do is listen in on the traffic between them, as long as the logger is requesting frequency data and the radio is responding with it, which happens on pin 2 of the 9-pin connector. Then with the proper Y cabling or one of my serial boxes, the device can monitor the frequency and keep on tracking. But it stops working if the radio stops outputting data. You don't have to worry about Y cables with these Yaesu rigs. These newer ones have an independent USB port, not like the older FTDX 3000. So the radio or the device can actually send commands independently at a different baud rate, if you like, to the RS-232 connector, while the logging software uses the USB. Not the case with the older Elecraft K3. Some of them do have a USB port, but again, it's not independent of the 9-pin serial port. So again, you need the Y cable and a device operating in just listen mode as opposed to sending its own commands to the radio. ICOM rigs, as I mentioned, have the band voltage, but a better answer to get just the frequency is to use this remote connector, which is just a simple 3.5 millimeter mono jack, and it's like a 2-wire serial bus. It can go up to 19200 baud, but there's a very important menu setting that you have to set to make that port operate independently of the USB port. And some of their ICOM radios default to this setting, unlinked from remote. Remote is the CIV jack, if you will. And you definitely want to select unlinked from remote if you plan to connect a device like a band decoder or antenna switcher or tuner into that remote jack. What about amplifiers? Well, the solid state and broadband amplifiers, they often include built-in tuners So they need the frequency, but it depends on the model. Some communicate only by RS-232, some can get band data, some can get both. A few can handle ICOM CIV or even Ethernet. They'll change bands automatically before any RF is transmitted, and that's the goal. You don't want any hot switching eventually that wears out relays or burns up something or carbonizes something. So have everything switched before you do any transmitting. Most of them will have an internal RF frequency counter, kind of as a safety feature that you can, send a dot and without any band data connection, and the amp will switch to the right band. But that's causing some hot switching. So it's mainly used in case the RF for some reason doesn't match the band. But that can get you in trouble too, because sometimes the frequency counter gets fooled by an ARC or something else and ends up putting the amp on the wrong band. So here's an example of the ACOM 2000A amplifier, a popular high power amplifier, especially for RIDI operators, because it's one of the old tube types. And they give you 4 pins on their remote control head, the RCU, not the older black and white one, but the new color models all have this CAT connector. And their menu is designed to handle RS-232 communications with Kenwood, Yaesu, Elecraft radios. And they do have a circuit that allows the TTL pins, the 0 to 5 volt pins, to communicate with ICOM CIV. ACOM improved their amplifiers and their solid state models. They added, they still use the 15-pin connector, but now in addition to the RS-232 commands and the TTL type, they also added band data pins. You can see their pins 7 through 10 are the band data pins, and some more features all in the connector, including keying the amplifier. So one cable between the radio and the amplifier can provide it all. And that is the way to go with those amplifiers. You can get away with band data if all you have is the ACOM solid state amp and no ACOM tuner. But once you add the ACOM tuner, then you really need to get the frequency and not just the band. Ameritron has solid state amplifiers. These, of course, used to be sold by MFJ, and they're kind of out of business. So you may not be able to find these new anymore, but they are on the used market. And they have this separate device with the Ethernet style connectors at the bottom there that feeds the band data to the amplifier from your radio. But it's not using Ethernet, it's using the band data jacks. Elecraft KPA 1500 solid state amp, same pins as compatible with the Elecraft gear. There's a few pins that are different and not usually connected, but they do have an input there for ICOM band voltage. Nothing for ICOM CIV to get frequency. It can just get the band from an ICOM rig, but it doesn't have a built-in tuner. Their companion KAT 500 tuner doesn't have CIV support. But the Elecraft KPA 1500 amp, which has a built-in tuner, was enhanced to handle ICOM CIV as well as Kenwood and Yaesu RS-232 signaling. And it has a separate connector for all of those, in addition to the aux connector that it uses with the Elecraft gear. Flex Radio has gone kind of all in. They want their amplifier to work, the Power Genius to work with everything, and therefore they provided a convenient 9-pin CAT connector for serial. They have a band data input for band data, and they have a CIV connector, and this amplifier supports 2 radios in parallel for SO2R mode, and they put the band data pins on the bottom, and you would use the CAT connector at the top. So that one kind of does it all. The RF kit is a little harder to interface. With some radios, it has a CAT port that is just a USB connector, so you need an external, usually FTDI, which is made in the UK, USB to serial adapter to be able to communicate with a radio, and it doesn't work in listen-only mode, so it can be very difficult to interface this amplifier with older transceivers because of that. It does have a USB to CIV interface cable, and it does have LAN support, so if Ethernet could work, but it doesn't have any band data pins. SP Expert, kind of like ACOM, kind of wants to do it all. They put it all in one big 15-pin DA15 cat connector, and they can accept 2 radio inputs. As you can see from the diagram, they have band data pins, and they have RS-232 and TTL and ICOM pins, as well as amplifier keying and some other features on their cat connector. You don't need to use the relay or ALC jacks on the SPE amp if you use instead one 15-pin cable that carries those signals. So that's kind of convenient. So what about getting the antennas to switch right? So you need to connect a band decoder, which is a device that will drive relays to switch your antennas and bandpass filters and so on. Typically, the output of a band decoder would be enough power, 13 volts or so, to power a relay or ground, complete the connection by grounding a pin to like one line per band. So that's the output. And the band decoder, when you're using it with a tri-bander, can be configured or programmed so that it understands that, let's say, 10, 15, and 20 all go to the same antenna. So there's a lot of variety of band decoders that have been on the market. They used to be marketed by Array Solutions in Texas, who have closed shop. So now you can get them directly from the Hamation website. K7MI Larry is a very smart designer. I think he's done a very good job. Didn't use the Elecraft connector, but he used his 9-pin radio connector in a very clever fashion. And I'll show you that in a sec, I think. And it has an input from the radio and indicators and outputs that can drive relays in a variety of formats. He was very clever in his use of the 9-pin connector, used the standard pins 2 and 3 to do RS-232 data, and used 4 more pins to do the band data, and used one last pin to do ICOM band voltage, but it doesn't do CIV. Some of his devices do have a separate CIV port, as you can see. Let's see if my little highlighter works here. Right there is a CIV jack on his Bandmaster 5 decoder, and this older one has it too. So you don't need CIV on the 9-pin radio connector that I was showing you over here. This is an older band decoder from Elecraft. It's not one I would recommend much. It doesn't have real dedicated connectors even that are compatible with Elecraft's gear. It was designed to wire your own kind of connector to those screw terminals, and it doesn't have a visual indicator of what band it's decoded, unfortunately. Ham Plus, I think they're made in Brazil. They can decode ICOM, Elecraft, or Kenwood RS-232, and it can drive relays for their filters as well as their antenna relay switch boxes, the Ham Plus. And an important feature it has is these send in and out jacks, so that it prevents hot switching of things. If the radio is in transmit mode, you pass your relay keying line through those 2 jacks. And so when your radio is in transmit mode, it locks out band switches. The EA4TX remote box is a similar band decoder. These guys use the same connectors, but nobody uses the same pins. So a lot of custom cables I have built for folks to make all of this stuff work. And they do also have a PTT in, but they don't pass it through. So, but it can be used to prevent hot switching. This was unfortunately no longer on the market, but it was my favorite. It's the one that I used in my station for years. Extremely reliable band decoders from top 10 devices. I was disappointed that Elecraft took over the line, but decided they couldn't manufacture it. So you can find these on the used market, and there's a couple versions of it. I think it's a very reliable band decoder, but they do have some features you need to look into, some options before you buy. Unified Microsystems makes this set of kind of bare boards with the band decoder feature on it and a high side driver on it. I like to say some assembly required, because a guy sent me these and said, can you build me a box with connectors that does all this? And it took me, and it has a couple of switches, because one antenna I want to manually switch. And it took me many hours of work to build all these connectors and crimp all these things on and put headers on everything and get them all talking to each other and squeezed into the box. I'm not going to do that again. But if you're of the type who really wants to save a lot of money in your band decoder, have fun with this. So what about antenna switches? The band decoder can feed them, and some switches have the band decoder built in. And they're very good about preventing two radios from trying to transmit on the same antenna at the same time. That would damage something. So they'll lock out or have an open circuit to one rig if two rigs end up on the same band. And they use high power relays. The oldest one out there that I know about is the Ameritron RCS8V and RCS10. Again, with MFJ being out of business, these may be hard to come by, but they're surprisingly reliable for what they cost. They use very high quality relays in the high power relays inside the box. The box is very cheap plastic and it feels like it's, and the aluminum corrodes, but the relays last. And I've been amazed at how well this box works. They come with this manual switch, but then you replace that manual switch box that you see in the picture with an automated band decoder to feed 13 volts to the relay you want for each band. Hamation again makes this 8-pack 2x8 switch, which takes two radio inputs. It needs one of their band decoders because they don't have individual pins like some of the other boxes. This is not band data there. This is their proprietary what they call shacklan, or not even shacklan output. It's a special cable that from their decoders it goes to this box and does the same thing. Gets the radio on the right antenna. Flex Radio has their Antenna Genius, which has a built-in band decoder. That's what this 15-pin connector here is for. They also have a LAN interface, so it can automatically track Flex radios over the LAN, but I don't think that works with any other radios. And it uses the same band data pins on their connector as the PGXL Power Genius. The band data works fine, but again, even though they use the same connector as L-Craft, they didn't put the band data pins the same, so you do need a custom cable. And then Ham Plus also has this 2 input 6 output switch box that can do the same kind of thing, and it must be driven by a Ham Plus band decoder. I personally use this microham double 6 switch at my station with the top 10 devices driving it. 2 radios in, 6 monoband antennas on the output. Very robust, built like a tank. Very good isolation of the ports. You need a control cable from each band decoder. And then EA4TX has a similar 2x8 antenna switch box and a single control cable. And I'm a little vague on what goes into that control cable right now. What about bandpass filters? Again, this applies when you're doing single op 2 radio or a multi-op or field day maybe with more than one transmitter on the same site. It blocks the nearby signals. They're typically the low power, or 200 watt at the most filters. They prevent your harmonics from getting into other radios and prevent your receiver from being overloaded by out of band signals. They do make some high power bandpass filters. 403A has some of those, but they're very big and very expensive. And of course, they don't attenuate harmonics that get inside the band pass. But you do want them to switch to the right band automatically, because if you transmit in any power into the wrong band of these for very long, the smoke is going to come out. Here's one from Hamation that it's called the Bandpasser 2. It has a built-in band decoder. Same kind of idea with their remote connector there. Can be in band data mode or pin mode. There's a button you push on the front to switch it. Again, a clever design from Larry K7MI. Then there's the old-fashioned Dunestar 600, which requires the separate band decoder to feed. Its specs are not quite as good as the modern bandpass filters, but it can still work. OM Power has a bandpass filter, and it can decode all of those radios, including the icon band voltage. Again, the bandpass filter only needs to know your band. It doesn't need to know your exact frequency. So let's talk about automated antenna tuners. The idea behind those is you have to manually tune them, or at least press a tune button to have it go to each tuning segment of your antennas. And once that's set, if it knows the frequency of your radio before you do any transmitting, they can switch all the relays and capacitors and have a tuning solution already ready to go before you do any transmitting. And that should happen before you transmit. And it'll bypass itself automatically if the SWR is low enough that no tuner is required. And most tuners can remember multiple tuning solutions for a frequency, or some of them can. So if you have an antenna with different SWRs, it kind of figures out which one you're using and goes to that solution quickly. Elecraft KAT500 is an automated antenna tuner. It's really made to work with Elecraft radios, but it does have this PC data jack that can be wired to a Kenwood RS-232 port. So it can get frequency data from Kenwood or Kenwood compatible radios. And it has the keying lines in series so that while the tuner is moving, and this is important, it opens the keying line to the amplifier so that the amplifier can't feed high power through the tuner while it's finding a match. It's a very important feature. The Tuner Genius has the same feature. It accepts 2 radio inputs, same connectors as the Power Genius and Antenna Genius. They added CIV because it needs to know the frequency. And it has the safety of the input-output. One downside of this design is, for some reason, they don't close the output until 6 milliseconds after the input closes because they're using a relay behind those 2 RCA connectors. And that means you need more PTT lead time than you would think to prevent from hot switching your amplifier, because the output of this is keying the amplifier and it unkeys the amplifier or doesn't allow the amplifier to be keyed while it's tuning. This one is a little hard to get these days. The Kessler AT Auto, I think it had limited radio support for Kenwood type serial port data, and it was an optional board that you could add to it. Step-IR antennas have various controllers. You see the SDA 100 on the left and the optimizer, or sometimes called SDA 2000, on the right. And it has these data in and data out connectors, and data in is what gets serial data. It doesn't do band data. It needs the actual frequency of your radio to go to the right tuning segment. And it will automatically move the antenna when in auto track mode. You do need a custom cable, but it's actually a standard serial cable with just a couple of pins shorted, so you can build your own. And it does have, and it's important to use, this PTT connector that I see in this picture here. It's a 3.5 millimeter stereo jack, and it simply shorts tip to ring normally, and while it's tuning, it opens that connection, and that can unkey your amplifier and prevent high power while the antenna is moving, and that's something I highly recommend doing. Waymo has a similar connector, and they used this weird 3-pin connector for the PTT, but it does the same thing. And it also has a CIV jack. So let's say, how do we get all this to connect together? You might remember this chart from earlier in the talk that showed all of the gear talking to itself without any computer involvement in most cases. So what do we do to make all that work? Well, you can buy pre-made interface cables for many of these, but some of them you have to be careful. They may only provide band data and keying, and instead of giving you the exact frequency. So you need to look at the specs of these cables very carefully. And you can try to build your own because everything is documented, all the pinouts and stuff and all the manuals. But when you want to have more than one device tracking your radio, that's when things get kind of complicated. Sharing band data outputs can usually work, but sometimes you need a little more boost on the signals. And a single RS-232 connector to multiple devices, that's tricky. You can't just slap a Y cable on a RS-232 connector and expect it to work. Only the RxD pins, the receiving data pins, can be wired in parallel. You cannot wire 2 transmit data pins in parallel. It's like trying to wire 2 transmitters to the same antenna. It doesn't work. So you can use an ordinary 15-pin Y cable to split band data connectors on Elecraft gear. A shameless plug here, I did create something called the Y box, which is like a 4-way Y cable as well as a breakout box for some of the pins on your connector that Elecraft uses. For example, the FSK keying pin I break out to an RCA and a PTT, a second PTT input, and some other outputs there. A typical configuration for that would be, for example, an Elecraft radio, and then an Antenna Genius band decoder, and the Elecraft amplifier would go through. And by connecting 12 volts in, as I've done here, which isn't required, but that will automatically boost the voltage to the band data jacks on the Antenna Genius. Turns out the Antenna Genius doesn't really need those, but the Power Genius does. The Power Genius band data pins draw too much current from Elecraft gear, so you need to pull those pins up to 12 volts with a resistor, and all that's inside the Y box. What about sharing the RS-232 port? As I mentioned before, you can't put two pin 3s to transmit data lines from like a PC and an amplifier in parallel. They're going to cancel each other out. It's just not going to work. So what you can do though is, so that's why standard Y cables don't work. What you can do is have one radio, typically one device, typically the PC. Its transmit data line is connected to the radio and sends commands to the radio. What frequency are you on constantly? And then the received data, the data goes the other direction back to the PC. That comes in on pin 2, and that can be wired safely in parallel to all the listeners. And then most devices can just listen and get to the right frequency that way. But there are some exceptions. What the message they're listening for varies from between ACOM and SPE and others. So here's a typical way I would use the serial box. And that is, for example, an FTDX 5000, which just has a single 9-pin cat port. The USB version of the box has an FTDI USB to serial adapter built in, so that goes straight through to the radio. And then I've got the step-IR antenna listening in on that traffic and the ACOM 1200S amplifier listening in on that traffic. And these cables, these external ones, are all stock 9-pin and 15-pin cables here and here. All of the custom cabling and wiring is done inside the box with little jumper wires. This is, wrapping it up here, this is one of the newest devices on the market. It does some of the same things as the serial box. It actually will convert band data and CIV and RS-232 to a common format that can feed an amplifier that otherwise wouldn't understand that format. And it's designed not necessarily for SO2R stations, but it's designed for stations with up to 3 exciters and maybe 1 amplifier. And only that and 1 TX inhibit that they need for all the radios. So this is their block diagram. It's a little busy. I don't know anybody who has one of these devices yet, but it's made to go in combination with their Trio switch, which is basically a way of sharing 3 radios between 1 amplifier and 1 set of antennas. So some folks may need that kind of solution. All right, so just to sum it all up here, some key recommendations. As I mentioned earlier, when possible, let the transceiver drive all the devices. Don't have to rely on PCs to do it. Sometimes you have to use a PC and it's USB or serial ports to drive other devices. But my recommendation is there's a lot more reliability if you don't rely on the PC to do that part. Use the band data when you don't need the frequency, and use the RS-232 or CIV data when frequency control is essential, as with tuners and step-IR controllers. And in some, use the off-the-shelf solutions, as we call it, if you're not comfortable wiring your own interconnection cables. But in other words, if you don't know what you're doing, don't do anything. Get some help from somebody who does. So these are some references. This presentation, a copy of it is on my qrz.com page in a PDF format, and also links to my little interface boxes to help share devices if you need it. And you can always reach me very easily at N6TV@ARRL.net. So I'm ready, David, for any questions or comments that came in on any of the inputs. So fire away.
Okay, thank you very much indeed, Bob. I don't think I'll be alone watching this presentation and not realising there were so many products out there. I mean, it's extraordinary, isn't it?
I've had to learn about every one.
Yeah, to do this talk. I mean, I just didn't know that there was this much there. But anyway, thank you very much indeed for the presentation. These boxes could all make your life a lot easier. And so if you have any questions or comments for Bob, we haven't had any yet, but I know you've probably been intently watching it, then please do ask it now. One thing I was thinking about as we were doing this, Bob, I know that the number of formats or the configurations and the protocols between the manufacturers has never been consistent, but at least now with most modern rigs now, they have that USB, Universal Serial Bus connection that makes some of the wiring at least a bit easier, doesn't it? But you're still advocating using one of these boxes often instead of a computer, are you?
Well, the USB connection on a radio works great with a PC, which has the device driver for the USB to serial adapter. And of course, in the future, hopefully everything will go over Ethernet cables instead of USB or so on. But the peripherals right now, they're not full computers, most of them. So they tend not to have, the exception was the RF kit. It was one of the few that required an external USB to serial. And you can do a USB to USB cable on it, I think. But to date, most of the external devices don't want to get as fancy as having support for USB directly in them. And so, at least not for talking to radios. They still want to talk to radios over the legacy pins, as opposed to trying to communicate with the radio's USB port. Most radios just have one USB port, so that's going to be occupied by your PC logger anyway. So it's just not available for a device like a band decoder or a Tuner Genius or something to use that. Then again, with Ethernet, a lot of the cabling is omitted because they can all communicate with each other over Ethernet very quickly.
Over a network. I know that
right.
Our club can't be the only one where, we've got laptops that we use for logging and things on field days and events like that, but they all have to have good old-fashioned labels on each one because a lot of devices like loggers and other products like that, they need to be plugged into certain places. I used one actually at a special event a couple of weeks ago, and it said you must plug the mouse in here, you must plug the keyboard in here, and that sort of thing. Otherwise, it shouldn't really be like that, I suppose. But that's
there's a good reason. There's a good reason for that, actually. Well, not a good reason, but there's an explanation for that, and that is that a laptop, even one with just a couple of serial ports, has different internal, what they call USB hubs. It's like an external USB hub would plug in and give you maybe 4 or 5 USB ports. Laptops and the others have several of them. And every time you connect something like a radio to a different USB port on your PC, if it ends up being on a different internal hub device, like maybe one hub for USB 3.0 and another hub for USB 2.0, the Windows especially sees that as a brand new device and thinks it needs a whole new COM port number. So everything that was working on the old COM port numbers suddenly doesn't work when all you did was move the USB cable from one port to another on your PC. And all of a sudden the sound card's different and everything's messed up. So that's why it happens. I think Macs and Linux boxes aren't so finicky. But in Windows anyway, every time you move a USB cable, and I have a whole talk also linked on my QRZ page about everything you want to know about USB and serial ports.
It's amazing.
That's
isn't
the
it?
explanation.
USB, it doesn't feel new anymore, but I can remember when Windows 95 came out and that was going to support USB. I don't know if there was anything before that, but that's the one I remember. And it was all a bit flaky then, and you mustn't plug your device in before you've installed the driver or you'd have all sorts of trouble. And that sort of thing. But it's amazing this long afterwards. So that was 95. So 30 years on, and we still talk about legacy ports and COM ports. Most computers don't have the physically serial ports and things on now, but I guess you can still buy cards with serial ports on them, I guess.
You can for mini towers. You used to be able to buy cards for laptops that would give you the 9-pin serial port. But you don't need those anymore because the good old UK produced this FTDI, very high quality USB to serial adapter. So you plug a USB on one end and you got a 9-pin serial on the other and you're good to go.
Yeah, that was easier, wasn't it? I remember. Well, we haven't had any questions. I don't know, we've bamboozled everybody and they're just thinking, oh my goodness, all those things. But anyway, we did talk about this before because, unusual this, but on Monday, Peter, M0RYB, sent me a question for something that he particularly wanted you to answer tonight. Now, I must preface this by just saying, before I read it, that actually he found his own answer by cheating a little bit and looking at your slide deck to get the answer. But I still think it'd be worth covering this and explaining to people because it must be a question that comes up often. So this was Peter's question originally. A group of us have recently set up a multi-2 station. We have 2 K4 transceivers. Each is serviced by a Hamation Bandmaster 5 BMV controller, Hamation bandpass filters, and the RF is fed to a Hamation 8x2 antenna switch. We've seen a lot of those sort of things tonight, haven't we? The BMVs read band map data from the rigs and select the appropriate bandpass filter and antenna. The first transceiver on a band grabs the antenna and disallows the second transceiver access to that antenna. But our research has highlighted the need for a hardware lockout mechanism to ensure the second transceiver does not inadvertently transmit on that band, as it would be transmitting into a high SWR open circuit, because I guess it wouldn't be connected to an antenna. Unfortunately, searches of Google and ham outlets such as DX Engineering and 403A have not helped. Are you able to provide guidance as to where we might look further? So just talking maybe specifically about this, but also just generally about the problem, what happens to that second transceiver when there isn't an antenna available for it?
Yeah, the radios he has there, did he mention it was a K4, Elecraft K4 or K3A? In that, either both of those radios have a pin on the accessory connector called TX inhibit, and that essentially prevents the radio from transmitting any RF while that pin is asserted. You can make it high inhibits or low inhibits. Unfortunately, I'm not aware of any two radio boxes like we're talking about. I mean, the 2-port antenna switches or band decoders that automatically turn on that inhibit pin. The Trio device that I mentioned earlier, but it's not really designed for his type of station, does have a way of inhibiting the out of use transmitters. It has a connection for that. So when you have 3 radios to 1, it takes care of inhibiting the unused radios. So some type of intelligence circuit, some kind of software would be needed to, on a PC, for example, to detect which radio got the antenna first and automatically turn on the inhibit pin. I am not aware of automated solutions that use the inhibit pins, because not all radios have them. Icon radios in particular don't have an inhibit pin. So it's actually a tougher problem. I'm not sure which solution he came across. I do have a simple SO2R lockout circuit, but it's designed to prevent 2 radios from transmitting at the same time. It's not designed to prevent 2 radios from transmitting only when they ended up on the same antenna port or the same band.
And it's difficult, I guess, because even if you made a clever little box which maybe looked at the outputs of a radio and decided, oh, there's no load, or there's a bad load, bad SWR or something, if there isn't that inhibit pin on the transceiver or a way of switching it off, then you can't do anything with that information anyway, except maybe flash a red light or something like that. Yeah.
You could perhaps turn off Vox and rely exclusively on the PTT line and break that open. That's one way that I've operated at the K3LR station, and his original lockout system prevented the second radio from transmitting by essentially opening its key or paddle line and opening its foot switch line and keeping Vox off. And that was how that worked. So if you don't have an inhibit pin, turn Vox off and open the PTT line, so it's impossible to switch to transmit mode. But again, software can switch to transmit mode, and you can't inhibit that so easily. That's why the hardware inhibit is fail-safe when you can use it. So that's a good problem, and there may be from 403A some solutions for that kind of thing in his fancier SO2R boxes. Not aware of that feature. So it's a tougher problem to solve, but it's not unsolvable. There are hardware pins that would work, but you may need some type of program to trigger that pin when you need it.
It seems a long way, rather late, I guess, to have a standard socket, which could be even something as simple as a 3.5mm jack socket or something like that, just to transmit and inhibit. It seems that if there had been a format like that or something like that. By the way, Peter OM0OIB, who answered me that question by email, because we are transmitting this live, broadcasting this live, but there is a latency. He just missed, unfortunately, the fact that I was coming to his question at the end, but I think he found it useful anyway. Although he said he only found one solution to that, so I don't know which one you found was useful, Peter.
I'd like to know.
Well, if you can quickly, Peter, put that on. Be interested, because we're coming to the end of a program now. We've also had a comment from Andy M0NKR, and I think I know what you're going to say when I read it, but it does say, if not hardware, some contest software you can do via software. But I guess that comes back to your original point about not maybe depending on the PC?
Right. I'm sure in some situations you definitely would prefer to use the PC. I find, PCs get RFI problems, PCs can lock up, PCs require rebooting, but certainly it does give you a lot of flexibility and control if you want to put software in charge. And in some situations, it makes sense, for example, to do the COM port sharing that I talked about by using a software program like HRD or I think Win4K for Yaesu and so on. They have the ability to translate, for example, one radio's protocol to another. So if your device, for example, only understands the older Yaesu protocol command set and not the newer one, which is a problem sometimes, then you can use PC software to translate strings between the two so that they become compatible with the PC doing the work. So yes, there are times when it's useful to use a PC.
Okay. Well, Bob, it has been really interesting. Oh, just quickly now, I've just had a reply from Peter of how he found it useful.
Thank you.
He says, yes, thank you, very helpful. The solution he found is by EA4TX.
That's it.
Which specifically uses the inhibit pin on the Elecraft K3 and K4. So again, going back to that inhibit pin, because it's got a pin that enables you to hardware-wise prevent it from transmitting, but not all transceivers have that. But at least it's helped Peter anyway for this.
Yeah, I'm bringing up my slide on the EA4TX. Let me find it here, and then you can show it.
Okay, yeah, we can go back to that. Here we go.
If you just want to show slide 31, there it is. Pin 6 is inhibit. And the note 1, I remember looking this up, is not available on all models. Some of us do. I think it was something he added on his later model. And that is actually a useful thing. And I forgot to mention that this does take 2 radio inputs, not just one. So that could indeed detect both are on the same band and activate the inhibit. So that's a good solution. I had forgotten about that. So thank you for sharing that.
Excellent. Well, as I said when straight after your presentation, and I still maintain it, I just had no idea that there were so many boxes on the market to do this job. Some available, some maybe discontinued, but I guess you'll keep coming up on the auction sites and retailers and things. But it's been wonderful that you put this all together for us to show us what is available, and that this hopefully something for most people, I guess, covering most rigs. And we'd like to thank you again, Bob, for coming on to NARC Live today to tell us all about it.
You're very welcome. Thanks for the invite. I assume folks will feel free to email me questions if they happen to watch this later rather than live. Happy to help with that. And I will be in the UK in the summer of 26 for the World Radio Sport Team Championship, which I think is happening near the Norfolk area.
Absolutely, yeah. It is. I mean, actually, a lot of it is on our doorstep. Pretty much is in our county, and the headquarters is based just outside the county in, is it Cambridgeshire or Bedfordshire? I think it's Cambridgeshire, Huntingdonshire. So the actual headquarters. So yeah, we'll look forward to meeting you then. Then maybe you come and see us at the radio club if you're over for a little while.
Will do.
Be lovely to see you. Thank you again very much for tonight, Bob, N6TV.
So long.
Thank you. 7-3. There we are. Very useful talk. So many bits of equipment, and they're not radios and things. You just tend to think of the mainstream radios and things, don't you? Anyway, thanks very much again to Bob, and thanks to you for watching. Just to quickly remind you again what's happening at the club this coming week. On Saturday, we've got our monthly Kablensked at 10 a.m. on 7.123 megahertz with a talk-in on 145-250. On Sunday at 7 o'clock, the GB2RS News on GB3MB, and on Monday also on that repeater at 7:30, we've got our Monday Night Net. And then next Wednesday, a week from today, on May the 14th, we're meeting at CNS School for a social informal and also Bright Sparks for our younger members. But that is about it now. Don't forget to keep that news coming to us. But until next time, when we meet in 2 weeks' time on NARC Live, from Tammy M0TC.
Bye-bye.
And from me, David G7ERP. Take care of yourselves. Look after each other. Bye-bye.